welcome. Myself Dr. Sayanti Chatterjee, Associate Professor of Electrical and Electronics Engineering Department of Institute of Aeronautical Engineering. Today I am starting my topic on network analysis. This is a third semester subject and the paper code is AEEC 05. Today my topic is Introduction to Network. So before starting, I will discuss about what is the objective of telling the subject. First of all, after reading the subject, after learning the subject, students will be able to understand three-phase system, star and delta connected systems, and perform three-phase power calculation for balanced and unbalanced load. They can study the transients using differential equations, Laplace transform for series and parallel circuits. The concepts of locus diagram for series and parallel circuits and discuss it for network functions and stability criteria also they will learn. They will learn the steady state response of complex electrical circuits with AC supply and application of concept of electrical resonance. And last of all, it will discuss about the different types of filters and discuss about their characteristics. So today my topic is based on the necessary mathematical background of the DC and AC circuits. So today my topic is basically based on the mathematical background of the transient analysis of AC and DC circuits, and today I will start the basics of the networks. So these are the objectives of my class. Next I will discuss what is the outcome if they learn the subject, what they can achieve. So we can broadly divide the outcomes into the three parts. One is the Bloom's word, what they want. Next one is the what they will want and the behavior. So after this they will discuss the steady state response and resonance of the electric circuits of the AC supply. The second is the understand the concept of initial conditions of the RL, RC, RLC elements to determine the transient response for the first order and second order circuits using the differential equation. Next is illustrate the locus diagram of series and parallel circuits and describe the network functions. Solve the relation between line and phase of star delta connection system to analyze the balanced and unbalanced load. Demonstrate the operations of wattmeter to measure the three-phase active and reactive power. And the last one, which is very important, develop the various types of active filters and understand their characteristic. Execute the digital simulation. Also, we will discuss some simulation result using MATLAB also. So today my topic, my first unit or my first few lectures will be based on our CO1, and it is the discuss the steady state response of the electrical circuits to the AC supply. So first when we will start any program, the first question what will come in our mind, what is the circuit and network? Actually in our second sem we have a subject electrical circuits, and now the subject is network analysis. So the basic difference, we have to discuss the basic difference between the circuit versus network. So first we will tell what is a network. A network is an interconnection of the electrical elements that may have or may not have any closed path. So if you can see now, if it is an open circuit, that there is no closed path, all are the open path, then we can tell this condition is a net. This condition, if we think about this condition, this is a network. All the elements are connected, but it is open only. On the other hand, if a circuit has an interconnection of electrical elements, but it must have at least one independent source. Here you can see this is an independent source, and a closed path, then only we can tell it is a circuit. So we can tell all the circuits are network, but all the networks are not circuits. See, I have drawn one circuit like this. Is this a circuit? No. Why? Because we have many resistances but no active source and there is no closed path. So I have one more. Is this a circuit? No. This is also not a circuit because though R, L, C, active source, everything is there, but there is no closed path. But if we go to a circuit, we have some active source. Active source means which will give us power. So which can give the power. So like voltage source, current source. So this is a closed path. So this is a circuit. But these are all network. Network means only interconnection of the electrical elements. It means only the interconnection of the electrical elements. Then if any connections are there, but if this is a circuit, nothing is interconnect. This is not a network. This is not a circuit. So all the circuit must have a closed path, means it is an interconnected. It should have one active source. So when it is connected, this is a circuit condition. When it is open, it is a network condition. So while we will discuss, then we will come for a three important topic on circuit: open circuit, closed circuit, and short circuit. So first of all, what is an open circuit? So first we will discuss about the open circuit. You can see in down I have drawn three pictures. One is open circuit, one is closed path, and one is short circuit. So what is the open circuit means? So what is the meaning of an open circuit? In open circuit, the electric current or the charge particle doesn't flow from the active energy source to the connected load or component due to the incomplete path. You can see here there is a battery which is active, but we have opened the switch. Switch is open, and this is the graphite which is not a conducting path. So what will happen? From the battery, the charge will not flow to the light or to the bulb. So it is an open path like network, but though it is interconnected, it is an open path. So we can tell it is an open circuit condition. Network is an open circuit condition. What is a closed circuit? So unlike the open circuit, what is the closed circuit? An electric current flows from active energy source to the active energy source from the active energy source to the light or to the connected load or other components which is closing the path. So what is closed circuit? The electric current. What is electric current? Current is nothing but the rate of change of charge. Rate of change of charge. If electrons flow through any conductor, current will flow in the opposite direction of the electrons. So in a closed path, the electric current or charge particle flows from the active energy source to the connected load or other components due to the closed path. So it is a closed path due to the closed path. You can see here the switch is closed. So current will start and it will flow through the closed path. So this is a special condition of open circuit. This is the special case of short circuit. So these are the closed path. Now one more thing come. What is called the short circuit condition? What is short circuit? In our network analysis subject, we will get a lot of example of the short circuit. So what do we mean by short circuit condition? You can see here there is an active source but there is no voltage drop. What is the meaning of a load? Load means when current flows through anything, if there is any voltage drop, we can call it load. So if there is no load, no voltage drop, we can tell it as the short circuit. So voltage tends to 0 and current tends to infinity. You can see there is no voltage drop. So voltage tends to 0 and current tends to infinity. In the short circuit condition, maximum amount of current will always flow in the circuit. This is a special case of the closed path, though it is a closed path, but there it is known as the short circuit condition. So till now we have discussed what is a network. Network is a closed path. Network is an interconnection of many electrical equipment. Number 2, we discussed the circuit, which is a closed path and having a active source. Then we discussed about the open circuit, closed circuit and short circuit condition. Next, the important topic we will discuss the series and parallel circuit. As if I go for a syllabus, there is a big emphasis is given on the series and parallel. So it is very basic things, what is series and what is parallel. So in these circuits, all the electrical elements, whatever the electrical elements, voltage and current sources, inductors, capacitor, resistors, diode, everything are connected in series. You can see this is the voltage source. All are connected in series. So if I want to draw it, how we can draw? This is a voltage drop. Then first one bulb R1. Second bulb R2, third bulb R3, all are connected in the series connection. That is, there is only one path for traveling electricity. So these are the single branch circuit. What is happening? This total voltage is here. If the current is I, according to the Ohm's law, there is a voltage IR1. This is a voltage drop IR2 and this is another voltage drop IR3. So what is the voltage we are getting here in the R1, R2, R3? Voltage minus IR1 minus IR2 minus IR3. So if we want to measure the voltage, we will get V minus IR1 minus IR2 minus IR3 is equal to 0. The total voltage will drop in the different loads. But throughout the circuit, the current is only constant. You should remember, in a series circuit, throughout the circuit, the current is the only one thing which is constant. Next, because if we keep one multimeter and if we keep in this 2 position, we will get the voltage drop. Here also we get, but if we keep here and here, we will get the voltage V minus I into R1. If we keep one multimeter here and here, we will get the voltage V minus I into R1. Next, we will go for the parallel circuits. In the circuits, all the electrical elements are connected in the parallel. So if I want to draw it, so it is all the circuit parameters are connected in parallel. That is, there are many paths for traveling the electricity through the branch. So if we think this is the voltage, the current will flow here, here and here. The current is dividing. So if we want to think about the parallel circuit, in every branch voltage is constant. For every branch voltage is constant, but the current is not fixed. This I current is dividing at IA1, I2, I3, or we can write I is equal to I1 plus I2 plus I3. This equation is known as the Kirchhoff's voltage law or KVL. This is based on the KVL and this is based on the Kirchhoff's current law KCL. In the series circuit, the voltage is the constant. In the series circuit, current is constant, but in the parallel circuit, the voltage is constant. Next, we will discuss about the Now we can discuss about the different combinations of the series and parallel circuit. So it may be series and parallel circuit means R and L can be parallel, R and L and C can be parallel. So any passive elements can be added in the different types of series and parallel connection. If you see this last one, all RLC are connected in different parallel combination. So as per we discussed till now, we have discussed about the different combinations of the circuit parameters. So what is the circuit parameters? Circuit parameters are broadly divided into two parts. First one is the active circuit parameters, second one is the passive. What is the meaning of active circuit parameters? Active circuit parameter means which can dissipate which can give the energy like voltage source, current source. So these are the active which gives the energy. On the other side, what is the passive circuit parameter? Passive circuit parameter means which can dissipate or store the energy. Which can dissipate or store the energy. So this is the circuit parameters. So first one is very common, which is known as the resistance, and we write the resistance by this sign. This sign tells about the resistance. You can see this is the, already everyone knows this, just for a quick revision. So what is resistance? Resistance is nothing but the property of resisting the flow of electrons or currents. So what is resistance? Resistance is the property of any material which will oppose the flow of electrons or current, which will oppose the flow of electrons or current. So we can get the definition of the resistance from the Ohm's law. What the Ohm's law tells? When the temperature, pressure and other physical conditions are constant, the current flows through any conductor is directly proportional to the voltage across the conductors. So current is directly proportional to the voltage, or we can write voltage is directly proportional to the current. We can tell the voltage is directly proportional to the current, which means if we are taking the proportionality constant, this is R, and R is known as the resistance of the conductor. So what is R? R is equal to V by I, where V is the instantaneous voltage in volts, R is the resistance in ohms, and I is the instantaneous currents in the ampere. R is equal to V by I. So we can write from here that the resistance is written by the unit of resistance is ohm, and 1 ohm is equals to the unit of voltage is V per ampere. Volt per ampere is the unit of the resistance. Volt per ampere, V by I. So I is equal to, we got the equation, I is equal to V by R. Next we are moving to our next circuit parameters, which is known as an inductor. So inductor we generally draw by like this. So inductor example is lots of inductor like inside the bulb, inside any coil, we can find the inductor. So inductor is a passive component, as I told. Resistance, inductance, capacitors all are the passive components, and inductor is a passive component that is used in most power electronic circuit to store energy. One thing you have to remember, that the resistor is used for the dissipating the energy. Dissipating means when current will flow through a resistor, the resistor becomes very hot. You can get the example in the heater, electric heater. This is a high resistance nichrome wire is there, nichrome wire. When current flows through the nichrome wire, what will happen? It will create some energy, and according to the Joule's law, the heat energy is equal to I square R into T. So I square R, current, how much current it will flow through any current, that square into R into T. So the use of the resistance is to dissipate the energy. Whereas when we are discussing about the inductor, what is the use of an inductor? Inductor is used to store energy. Inductor is used to store the energy in the form of magnetic energy when electricity is applied to it. When we are, it is basically it has a magnetic energy, store the electrical energy in the form of magnetic energy when electricity is applied to it. So when there is an electricity is applied to the conductor, it will store the energy, and the energy value will be half Li square. So what is the equation of the inductor? What is the unit of inductor? The unit of inductor is Henry. The unit of inductor is Henry. And what is the voltage? We know voltage is equal to the voltage across the inductor is equal to L di by dt. What is the voltage across an inductor? Voltage is equal to L di by dt. So what is I? I is equal to 1 by L integration of V into dt, where V is the instantaneous voltage, L is the inductance in Henry, as I told the unit is Henry, and di by dt. What is di by dt? The rate of change in current, not the current, not the change in current. Rate of change in current is known as the rate of change in current is known as the inductance. The rate of change, that V is directly proportional to the di by dt. So V is equal to L di by dt. Voltage is directly proportional to the rate of change of current, and so V is equal to L di by dt. Next, we are moving to our third important electrical circuit passive component, and that is capacitor. So capacitor is a device in which the electrical energy is stored. This is also and here the electrical energy is also stored in the form of electrical energy form only. In inductor, the power is stored in the magnetic power form, but in the capacitor is a device where the electrical energy can be stored in the electrical energy form. So here we can draw it by capacitor C. And what is the energy? Energy is equal to half C V square. C is the value of capacitance, and the unit of capacitance is generally we write it by farad. How we can get? So whenever there is a rate of change of voltage, in the case of rate of change of current, the inductive property increases. But if there is a rate of change of voltage, what will happen? V is equal to C dV by dt. So voltage is equal to 1 by C integration of I dt. So what is the I? I is the instantaneous current through the capacitor. What is I? I is the instantaneous current through the capacitor. What is C? Sorry. What is C? C is the capacitance in farad. And what is dV by dt? Instantaneous rate of voltage change, volt per second. So these are the use of the capacitor. So capacitor is basically used for the energy storage and the filter application, as we discussed in the last step, last module of your syllabus is about the filter. It will discuss about the filter application. Next we will discuss about the sources. So as we discussed, there are two types of sources. One is DC source and another one is the AC source. DC source means the current is flowing in a constant direction, and if we plot it, we can get one straight line. AC source means it has a positive peak, negative peak, and it is the alternating current. AC means alternating current. What is the meaning of DC? DC means direct current. So you can see it is changing continuously. So if we want to write the equation of this, that DC is always constant. DC means direct current, it is a constant, this value is A. But what is the equation of the AC? Vm sin omega t. Though we are using the sinusoidal equation, but it is not necessarily it should be sinusoidal. It may be any type of alternating. It may be triangular form. AC may be pulse form, so it may be different source, but for our supply we are taking as the Vm sin omega t. Next we will discuss about the phase and phase difference. What is phase? Phase means the angle between the voltage and current. The angle between the voltage and current. And what is the meaning of the phase difference? The difference between the angle. So the angle between the voltage and current. Now when current flows through a resistor, what will happen? If the current is flowing through a resistor, what is happening? So you can see the voltage when the current is flowing through a resistor, the volt, and we are discussing about the AC alternative current because it have the positive and negative and alternating in nature. We are not concentrating about the DC. So when the current, when the voltage is flowing through the resistor, what is happening? The voltage and current both are in phase. The phase difference we write with the angle phi. So what is the value? VR is equal to, if VR sin omega t, then what will be the value of IRT? IRT will be also IR sin omega t. So there is no phase change. All are in the same phase, and in this case power is equal to voltage into I, because we know power is three types. First one is called, power is three types. First one is called the active power. What is VI cos phi? Phi is the power factor angle or the phase angle, the angle between voltage and current. Then we are discussing about the reactive power. We are discussing about the reactive power, VI sin phi, and then we are total power apparent power is equal to V into I. So if we write Pi cos phi and the angle between voltage and current is 0, so we can write Vi cos 0 is equal to Vi. Now if we are thinking about the inductive load, what is happening in the inductive load? You can see voltage and current. When current is current is lagging in this condition. Voltage has started before, but current has started after some angle. So this is called the lagging angle. So if the voltage is Vm sin omega t, so it is lagging by phi angle. So it is going behind. When it is 0, it is as the negative value. It has the negative value. When it is 0, it has some positive value. So voltage is leading, current is lagging. Now we are discussing about the capacitance. In the case of the capacitance, this is the voltage and current. Now you can simply see that if the voltage is again Vm sin omega t, current is actually lagging. Current is actually leading. Because current has started before. So current is actually leading. So we can write V is equal to Vm sin omega t and IC is equal to IC sin omega t plus phi. Now, one important thing here we have to discuss, that is, so what is the important thing here? We can remember using the civil rule. What is the civil rule? C means in capacitor. We will always discuss, remember it using the civil rule. What is civil rule? In capacitor. In capacitor, first I, then V. In capacitor, I is leading, V is lagging. Now, if we want to think about the second part, VIL, L means inductor. V is leading, I is lagging. So if you remember this, you can draw any type of phasor diagram. Now we will discuss about the J operator. In electrical, we know about the mathematics, we know the complex number. In the complex number, same thing we discuss in the case of the network analysis or throughout the electrical engineering. For leading and for lagging, we can use the J operator. Actually, we can call it as the I operator. But as in electrical engineering, small I means the current or instantaneous current. Instead of I, we are using the J. So J operator is a mathematical operator which, when multiplied with any other vector, rotates the vector by 90 degree in anti-clockwise direction. If this is the direction, if we multiply, say this is one x, so jx means, what is the meaning of jx? We are multiplying it by 90 degree. We can write it by jx. If so, jx is the anti-clockwise 90 degree. What is the meaning of j? J is nothing but the root of -1, similar to the imaginary number I. What is j? J is nothing but the root of -1. So, J operator is a mathematical operator which, when multiplied with any vector, rotates the vector by 90 degree in anti-clockwise direction. So, just like the symbol, we can use the number. So, if we are doing it 2 times, so minus 90, minus 90, so it is j square. What is this? J square means then 180 degree rotation. J square, and you can see what if j is equal to minus 1, what is j square? J square is equal to root of minus 1 square is equal to minus 1. So j square means if it is x, it is minus x. If we are rotating it by the 270 degree, so what is this? Minus j cube. So if it is plus jx, it is minus jx. 360 degree means minus 1 square means we are coming to the plus 1 means same rotation. So j means anti-clockwise direction we are moving to by 90 degree. Throughout our electrical engineering, we will use the J operator for telling about the leading and lagging. Leading means plus 90 degree, lagging means, so it depends, it is leading by how much degree. So our main aim of this chapter is the AC circuits. Details we will discuss in the next class, but today we will discuss about the representation of the phasors. Already we discussed about the phasor, and we have discussed the J operator. Now, as we are basically emphasizing on the AC circuits, so we will discuss about the various methods of representing the phasors. Remember one thing, as in our daily life we are using the AC, the main application of electrical engineering is in AC only. So first we will depend on the symbolic notation or rectangular form. What is the meaning of rectangular form? There are 2 types of form. You will study in details in your electromagnetic field, but for just simple discussion, rectangular form means we can divide. This is the x and y, which you know the normal plane. This is known as the rectangular form. What is this? This is known as the rectangular form. One is x-axis, one is y-axis. We can give some point P 2, 3. What does it mean? In the x-axis it is going for 2. For the y-axis it is going for 3 unit. This is 3 unit. This is 2 unit. So it will create like a rectangle. So this is called a rectangular phase. While now we are moving to the electrical engineering. See, this is a mathematics. So when we are doing about a rectangular form, it is x. It is not y. We will, as this is the 90 degree, so we will write it jy. And the point P, so it will be 2 plus j3. 2 plus j3. If I am telling one point Q and it is 2 minus 3, so what will be the point? 2 minus j3. As plus 90 degree and minus 90 degree, we are writing by j. So this is called this is y-axis. We are representing the y-axis by j notation. Next very important after this is the polar form. So what is the meaning of the polar form? Polar form means any point, any location we can tell in a polar form. Polar means, so if I go for the complex number 1, so any value has one magnitude as well as some angle, magnitude and angle. So if we think this is a 2 and this is 3, what is the magnitude from the center of this point? The magnitude is root of 2 square plus root of 4 square. 4 plus 9 root 30 unit. 2 square plus 3 square is equal to root 30 unit. What is the angle? What is the angle phi, which is known as the phase angle? So if we can write from the circle, tan inverse y by x, tan inverse 3 by 2. So this is the angle. So this is the magnitude, this is the angle. Say this value is, I am taking one more example. Say this value is 4,3. So what will happen? This is the 4 square plus 3 square. 4 square means 16. So root of 25. So it is coming 5 unit. What is this? 4 by 3. So whatever the angle, say this angle is 63 degree. So in the polar form, how to write the polar form? Polar means the circle. The general form of a circle is r j theta. What is the general form? R at an angle j theta. So what is the unit? 5 at an angle j 63 degree. So this is the angle. This is the angle. This is called the polar form. What is the exponential form? Exponential form means magnitude exponential of j theta. So what will be the value? 5 e to the power j 63 degree. So these three are the most common example, most common use of the exponential form. And last one is the trigonometric form. Trigonometric form means we can write the equation in the sine and cos form. So if we know the angle, we know the value. What is this? This is the this is the cos and this is the sine. So what will be the value? 5 cos phi 3 5 sine phi. So using this cos and sine function, we are using the trigonometric thing. So any AC circuit can be explained in the different form. So first one is the generally what we use in the maximum problem, that is the symbolic notation or rectangular form. Next important is the polar form. Third one is the exponential form, and fourth one is the trigonometric form. Let's do one example. So say one equivalent of the 3 plus 4j. Write the equivalent of 3 plus 4j. So this is our x-axis and this is our y-axis. This is our x-axis and this is our y-axis. So 3 means this is the x, y is equal to j4. As I told that y-axis always discussed about the j4. So 3 plus j4. So what is the magnitude? Square root of 3 square plus 4 square is equal to 5. Then what is the phase angle? Tan inverse y by x. What is the angle? The angle is tan inverse y by x. So what is the value? It is 4. This is 3. So we are getting the angle 53.1 degree. So in the polar form, we can write it 5 at an angle 53.1 degree. And in the exponential form, we can write, what is the exponential form? Magnitude, then exponential of j 53.1 degree. So this is called the analysis of the circuit form. This is the analysis of AC circuits. Now we are coming from the another example. A phasor represented by 20 e to the power j 2 pi by 3. Write it in the various forms of the phasor. This is a very good question. I am discussing one by one. Please try to understand. So a phasor is given by 20 e to the power minus j 2 pi by 3. So again we will draw it. This is our x, this is our j, y. What is the magnitude? Magnitude is 20. Which form is this? This is the polar form. This form is the polar form. And what is the magnitude of this? The magnitude of this is given by 20 e to the power j 2 pi by 3. So if pi is equal to 180 degree, 1 is equal to, so 2 pi is equal to 180 degree by 2 pi by 3. So this is the angle is 120 degree. So we can write, this is not polar form, this is the exponential form. This is the exponential form. So if I want to write it in the polar form, what will be the polar form? Polar form means, what is the meaning of the polar form? Polar form is equal to, how to write? Magnitude at an angle. So what is magnitude? Magnitude is 20, angle is 120 degrees. So we got our polar form. This is very easy. We got the polar form. 20 at an angle 120 degree. As this is minus, so this is minus 120 degree. Next we are going for the next one. This is the trigonometric form. What is the trigonometric form? Trigonometric form means, as I told, magnitude. Then if this is the magnitude, what is the magnitude? 20 and angle is minus 120. Minus 120 means in the anti-clockwise direction. Minus means it is in anti-clockwise direction. So it is 90 degree. This is again 30 degree mode. So this is our minus 120 degree. And what is the magnitude? Magnitude is 20. So if it is the magnitude, then we can write what is the so this is our x is equal to cosine and y is equal to sine. So magnitude cos angle plus j, because this is y, sine angle. So what is our magnitude? Magnitude is 20. Cos, what is the angle? Minus 120 degree. What is the angle? Angle is given as minus 120 degree. So magnitude 20 cos minus 120 degree plus j sine minus 120 degree. Or you can make it small, cos 120 minus is equal to cos 120 and j sine 120 degree. So this is, what is this? This is your trigonometric form. Next we are going for our first one, which is the rectangular form. So how to get the rectangular form? The rectangular form means A plus JB. Now we have to remember in the rectangular form how we are getting the polar form. Root of A square plus B square is equal to root of A square plus B square is equal to, we are getting the 20. Correct? So what is this? This also we can write it A cos. So this is our A and this is our B, obviously, because this is our X. Rectangular form, we are making it rectangle. So A is equal to 20 cos minus 120 degree. Cos 120 degree means half. So 20 minus half is equal to 10. What is this? Y? Y is equal to 20 sine minus 120 degree. So 17.32. So from the trigonometric form, we can get the, so first, if we are given the exponential form, first we will write the polar form, then we will write the trigonometric form, and then we can write the rectangular form. So we have to write this in a rectangle. We will discuss more problem in the later classes. So as I discussed earlier also, what is the meaning of instantaneous voltage? Vm sin omega t. And what is the current? Current is Im sin omega t, because there is no phase difference. So there is no phase difference. Already we have discussed. We are discussing one more problem. A 60 Hz voltage of 115 volt is impressed 100 ohm resistance. Write the time equations of the voltage and resulting current. And the point is started at 0. Point has started at 0 means it has started from the starting. So this is our V, and this is our current I. And we have to remember that there is no phase difference. So what is V? V has given that RMS value. V has given the RMS value. So what is Vm maximum? Maximum is equal to 2 root 2 V RMS. So root 2 into 115. So this is the V max. V max means peak value is the 163 volt. So if it is 163 volt, what is the equation? So what is the equation we are getting? We are getting Vm is equal to root 2 V RMS. So we got here 163 volt. Now what is the equation? We know V is equal to Vm sin omega t. So we can again write Vm sin. What is the meaning of omega? Omega is equal to 2 pi f. Omega is equal to 2 pi f. 2 into pi. Pi value is 3.14. And frequency, here the frequency is given as 60 Hertz. In this problem, the frequency has given us 60 Hertz. So 2 pi into 60 is equal to 377 radian per second. So what is the V3? 163 maximum value sin 377 t. As it is given, it has started at the 0 point. If it has not started at 0 point, we can write. What is IT? IT is equal to V max by R. V max 163 by R. R means here the given resistance is 100 ohm. So 1.63, as there is no phase difference, it is 1.63 into sin 373. So these are the textbooks I followed for this, and this is the internet source from where I took some figures. And thank you all.
Like, share and subscribe. Hit the bell icon for more updates.